Hello everyone. I welcome you all to Simplilearn. Today, we'll discuss the types of distribution in statistics. But before we move ahead, let's have a brief introduction on what is probability distribution. A probability distribution is a list of all of the possible outcomes of a random variable along with their corresponding probability values. And it is used in many fields, but we rarely do explain what they are. So, in this video, we'll discuss the three main types of probability distribution, that is normal, binomial, and Poisson distribution. So, let's move ahead.
So what is normal distribution? Normal distribution is a continuous probability density that has a probability density function which gives us a symmetrical bell curve. Now data can be distributed or spread out in different ways, but there are many cases where the data tends to be around a central value with no bias to the left or right, which means that it doesn't show any particular spikes towards the left or the right, and it gets close to a normal distribution. Half of the data will fall on the left of the mean and the other half will fall on the right. Now let's take a look at a graph which shows the height distribution in a class. As you can see, the average height is in the middle and the data to the left of the average height represents the short people and the data to the right of it represents the taller people. The y-axis shows us the likelihood of any of these heights occurring. The average height has the most distribution, or it has the most number of cases in the class, and as the height decreases or increases, the number of people who have that height also decreases. This kind of a distribution is called a normal distribution, where the average or the mean is always the highest point and any other point after that or before that is significantly lower. The resulting data gives us a bell curve, and as you can see, there is no abrupt bias or spike in the data anywhere except for the average height. So this kind of a curve is called a bell curve, and it's usually seen in a normal distribution. The reason we call this a normal distribution is because the data is normally distributed, with the average being the highest and all the other data points having a lower likelihood. Now we came across two terms which are associated with normal distribution: continuous probability density and probability density function. What is continuous probability density? Continuous probability density is a probability distribution where the random variable x can take any given value. Because there are infinite values that x could assume, the probability of x taking on any specific value is 0. For example, let's say you have a continuous probability density for men's height. What is the probability that a man will have the exact height of 70 inches? It is impossible to find this out, because the probability of one man measuring exactly 70 inches is very low. It is more probable that he will measure around 70.1 inches or maybe 69.97 inches. And it doesn't stop there. The fact is that it's impossible to exactly measure any variable that's on a continuous scale, and because of this it's impossible to figure out the probability of one exact measurement which is occurring in a continuous probability density. Next, we have the probability density function. It's nothing but a function or an expression which is used to define the range of values that a continuous random variable can take. An example of this would be to gauge the risk and reward of a stock. A probability density function is a statistical measure which is used to gauge the likelihood of a discrete value. A discrete variable can be measured exactly, while a continuous variable can have infinite values. However, for both continuous as well as discrete variables, we can define a function which gives us the range of values within which these variables will fall, and that function is known as the probability density function. Now let's take a look at standard deviation. What is standard deviation? Standard deviation is used to measure how the values in your data differ from one another, or how spread out your data is. A standard deviation is a statistic that measures the dispersion of a data set relative to its mean. The standard deviation is calculated as the square root of variance by determining each data point's deviation relative to the mean. If the data points are further from the mean, that means that there's a higher deviation within the data set, and then the data is said to be more spread out. This leads to a higher standard deviation too. Let's take an example of income in rural and urban areas. In rural areas, let's say such as farming areas, the income doesn't differ that much. More or less everyone earns the same. Because of this, our bell curve has a very low standard deviation and it has a very narrow peak. However, in urban areas, the wealth distribution is very uneven. Some people can have very high incomes and can be earning a lot, while other people can have very low incomes. Furthermore, the data distribution between these two income points is going to be more spread out because there are a lot more people living there who work in various fields and who have various incomes. Because of this, our standard deviation is more spread out and our bell curve will also have a wider peak. Now, how can we find the standard deviation? Standard deviation is obtained by subtracting each data value from the mean and finding the squared average of these values. Let's look at how we can do this with the help of an example. These values correspond to the height of various dogs. We can find the mean by finding the average of all these values, which is nothing but adding all the values and dividing it by the total number of values. The mean that we get is 394. This means that the average height of a dog is 394 millimeters. To find the standard deviation, first we need to subtract the height from the mean. This will tell us how far from the mean our data points actually are. Next, we will square up all of these differences and add them up and again divide it by the total number of values that we have. This is called the variance. The variance that we get in this case is 21704. Finally, when we find the square root of this value, we will get the standard deviation. The standard deviation here is 147. The standard deviation will tell us how our data points differ from the average, and it gives us a basic value suggesting how spread out our data is from the very middle or from the mean. So when we plot these values, this value 147 will mean that a curve will have a width of 147 points around the mean. Now, what is the standard normal distribution? The standard normal distribution is a type of normal distribution that has a mean of 0 and a standard deviation of 1. This means that the normal distribution has its center at 0 and it has intervals which increase by 1. All normal distributions, like the standard normal distribution, are unimodal and symmetrically distributed with a bell-shaped curve. However, a normal distribution can take on any value as its mean and standard deviation. In the standard normal distribution, however, the mean and standard deviation are always fixed. When you standardize a normal distribution, the mean becomes 0 and the standard deviation becomes 1. This allows you to easily calculate the probability of certain values occurring in your distribution or to compare data sets with different mean and standard deviations. The curve shows a standard normal distribution. As you can see, again, the data is centered at 0. This does not mean that the data necessarily starts at 0. This means that after standardizing, this point is where our mean will lie. In a standard normal distribution, the standard deviation is 1. So all the data points will increase or decrease in steps of 1. Let's better understand a standard normal distribution with the help of an example. Again, as you can see, the data is centered around 0, which is nothing but the mean. Let's again consider the weights of students in class 8th. The average weight here is around 50 kgs and the data increases and decreases in steps of 5. The data over here in this curve is evenly distributed along these steps. This is what a standard normal distribution will look like. We already know that the mean of our data is 50, and because the data is increasing and decreasing in equal steps, we can just standardize it and take it to mean that the data is increasing and decreasing in steps of 1. This is what a standard normal distribution looks like, and when you have a data which looks like this, you can always standardize it and convert it into a standard normal distribution. Now, standard normal distribution has a couple of properties which makes calculation comparatively easy. The first one is that 68% of the values fall within the first standard deviation, which means that 68% of all data values on this curve will fall between the range of -1 to 1 or the first interval ranging from -1 to 1. The second property is that 95% of the rest of the values are within the second standard deviation or from the second negative point to the second positive point. And finally, 99.7% of the values fall within the third standard deviation or from the third negative point to the third positive point. This makes calculations on standard normal distribution fairly easy. You can compare scores on different distributions with different means and standard deviations. You can normalize scores for statistical decision making using standard normal distribution. You can find the probability of observations in a distribution which fall above or below a given value. And finally, you can find the probability that a mean significantly differs from a population mean. Now let's take a look at z-score. So what is a z-score? A z-score is used to tell us how far from the mean our data point actually is. It is calculated using the mean and standard deviation, so it can be said that the z-score is how many standard deviations below the mean our data is. Basically, by using the z-score, we can get an approximate location of where our data point lies on the graph with regards to the mean. Now the z-score is given by subtracting the data point from the mean and dividing it by standard deviation. This can also be written as x minus mu divided by sigma. Now any normal distribution can be standardized by converting its values into z-scores. The z-score will tell you how many standard deviation from the mean each values lie. While data points are referred to as x in a normal distribution, they are called z or z-scores in the z distribution. A z-score is a standard score that will tell you how many standard deviations away from the mean an individual point will lie. A positive z-score will mean that your x value is greater than the mean, and a negative z-score will mean that your x value is less than the mean. A z-score of 0 will mean that your x value is equal to the mean. And again, to standardize a value from a normal distribution, all we have to do is convert it to a z-score by subtracting the mean from our individual value and dividing it by the standard deviation. Now let's see how we can find the z-score from data points with the help of a solved example. Let's do a case study. In this case study, we'll be taking the summary of daily travel time of a person who's commuting to and from work. All these values are in minutes. And using these values, we have to calculate the mean, the standard deviation, and the z-score. These values are as shown. As we can see, there are 13 values in total. Let's start by finding the mean. The mean is the average, and it can be gotten by adding all of these values and dividing it by the total number of values. This gives us a value of 38.6. The mean tells us the average of all our data points, which means on an average, he travels for 38.6 minutes to reach work. Next, let's subtract the individual values from our mean and calculate the variance and standard deviation. The values on the left give us the values that we get after subtracting it from the mean, and the variance can be calculated by squaring all of these values, adding up all of the squared values, and dividing it by the total number of values. At the end of the day, we get a variance of 140. To calculate the standard deviation, all we have to do is take a square root of the variance, which gives us a value of 11.8. Now, the mean signifies the average of our values, and we already know this. It gives us the average time which is taken to travel. But the standard deviation will tell us the average value of how much our data points differ from the mean. It tells us the deviation within our own data, and it tells us how far away on an average a point is from the mean. Now the value that we get is 11.8, which means that on an average, a single data point is around 11.8 data points away from the mean. Now let's calculate the z-score. The z-score is given by subtracting individual data points from the mean and dividing it by the standard deviation. We know that we have a standard deviation of 11.8 and a mean of 38.6. Using these values, we can calculate the z-scores for individual x values. Now we know that a negative z-score means that our x value is lower than our mean. But what does the number 1.06 mean? This means that the z-score for 26 is 1.06 standard deviations away from the mean. The negative symbol here means that our x value is less than the mean. And by how less? 1.06 times the standard deviation. Now we know that the negative value of a z-score means that our x value is less than our mean. But what does the number 1.06 mean? This means that the z-score is 1.06 times the standard deviation less than the mean. The same thing can be said for the z-score of 33. It is 0.47 times the standard deviation less than the mean. The z-score of 65 is 2.23 times the standard deviation more than the mean. That means it has to be added to the mean. The reason that we know it's more than the mean is because this has a positive value. So this means that using z-scores, we can know where our data points fall relative to other points on the graph. The z-score will tell us how far away from the mean a point is in steps of our standard deviation.
Basics and terminology. The first one is outcome. Whenever we do an experiment like flipping a coin or rolling a dice, we get an outcome. For example, if we flip a coin, we get an outcome of heads or tails, and if we roll a die, we get an outcome of 1, 2, 3, 4, 5 or 6. Random experiment. A random experiment is any well-defined procedure that produces an observable outcome that could not be perfectly predicted in advance. A random experiment must be well defined to eliminate any vagueness or surprise. It must produce a definite observable outcome so that you know what happened after the random experiment is run. Random events. Consider a simple example. Let us say that we toss a coin up in the air. What can happen when it gets back? It either gives a head or a tail. These two are known as outcome, and the occurrence of an outcome is an event. Thus, the event is the outcome of some phenomenon. The last one is sample space. A sample space is a collection or a set of possible outcomes of a random experiment. The sample space is represented using the symbol S. The subset of all possible outcomes of an experiment is called events, and a sample space may contain a number of outcomes that depends on the experiment. If it contains a finite number of outcomes, then it is known as a discrete or finite sample spaces. Now let's discuss what is random variable. A random variable is a numerical description of the outcome of a statistical experiment. A random variable that may assume only a finite number of values is said to be discrete. One that may assume any value in some interval on the real number line is said to be continuous. Let's see an example. Let x be a random variable defined as the sum of numbers when two dice are rolled. X can assume the values 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Notice there is no 1 here because the sum on the two dice can never be 1. Now that we know the basics, let's move on to binomial distribution. The binomial distribution is used when there are exactly two mutually exclusive outcomes of a trial. These outcomes are appropriately labeled success and failure. The binomial distribution is used to obtain the probability of observing x successes in n number of trials, with the probability of success on a single trial denoted by p. The binomial distribution assumes that p is fixed for all the trials. Here is a real-life example of a binomial distribution. Suppose you purchase a lottery ticket, then either you are going to win the lottery or not. In other words, the outcome will be either success or failure that can be proved through binomial distribution. There are four important conditions that needs to be fulfilled for an experiment to be a binomial experiment. The first one is there should be a fixed number of n trials carried out. The outcome of a given trial is only two, that is either a success or a failure. The probability of success remains constant from trial to trial. It does not changes from one trial to another. And the trials are independent. The outcome of a trial is not affected by the outcome of any other trial. To calculate the binomial coefficient, we use the formula which is NCR into p to the power r into 1 minus p to the power n minus r, where r is the number of success in n number of trials and p is the probability of success. 1 minus p denotes the probability of a failure. Now, let's use this formula to solve an example. Suppose a die is tossed 3 times. What is the probability of no 5 turning up, 1 5 and 3 5s turning up? To calculate the no 5 turning up, here r is equal to 0 and n is equal to 3. Substituting the value in the formula, we have 3c0 into 1 by 6 to the power 0 into 5 by 6 to the power 3, where 1 by 6 is the probability of success and 5 by 6 is the probability of failure. Calculating this equation, we'll get the value to be 0.5787. In a similar manner, to calculate the probability of 1 5 turning up, we'll replace r with 1 and n will be 3. So px1 will be equal to 3c1 into 1 by 6 to the power 1 into 5 by 6 to the power 2, which will come out to be 0.347. And for 3 5 turning up, we'll substitute r equal to 3 and the formula will remain the same and we'll get the value to be 0.0046. Now that we are done with the concepts of binomial probability distribution, here's a problem for you to solve. Post your answers in the comment section and let us know. A Poisson distribution is a probability distribution used in statistics to show how many times an event is likely to happen over a given period of time. To put it another way, it's a count distribution. Poisson distributions are frequently used to comprehend independent events at a constant rate over a given interval of time. The Poisson distribution was developed by French mathematician Simon Denis Poisson in 1837. A Poisson distribution is used in cases where the chances of any individual event being a success is very small. The number of defective pencils per box of a 6,000 pencil, the number of plane crashes in India in 1 year, or the number of printing mistakes in each page of a book. All of these examples can have use of Poisson distribution. The Poisson distribution can be used to calculate how likely it is that something will happen x number of times. A random variable x has a Poisson distribution with parameter lambda, and the formula for that is e to the power minus lambda into lambda to the power x divided by x factorial, where x can be the number of times the event is happening. The value of e is taken as 2.7182. Let's discuss some application of Poisson distribution. If you want to calculate the number of deaths per day or week due to rare disease in a hospital, you can use the Poisson distribution. In a similar manner, the count of bacteria per cc in blood or the number of computers infected with virus per week. The number of mishandled baggage per 1000 passengers can also have an application for Poisson distribution. Let's discuss one example to see how you can calculate the Poisson distribution. Suppose on an average, a cancer kills 5 people each year in India. What is the probability that one person is killed this year? We'll assume all these events are independent random events. So, by the formula, we have x is equal to 1 because we have to calculate the probability of one person that is killed this year. So p x equal to 1 will be equal to e to the power minus 5 into 5 to the power 1 divided by 1 factorial, which will come out to be 0.033, which will be near to 3.3%. So, the probability that only one person is killed this year due to cancer is 3.3%. Now, we have one question for you. Do try to answer in the comment section. Suppose the trains arrive at a railway station with an average arrival rate of 4 trains per hour. What is the probability exactly 6 trains will arrive in a 2-hour period? And here are our options. Please do let us know your answers in the comment section. So with this, we come to an end to this tutorial. I hope this video was informative for you. If yes, do share it to the maximum and don't forget to subscribe to our channel to never miss an update. Thank you again and happy learning.